Was that science fiction thing?
Well, it's a science thing, but what we're going to do today is not friction. Fiction. You watch the spoon.
It's moving. It's pretty strange music.
Well, this is electronic music. You see how that spoon bounces up and down like that?
It's really moving.
Okay. Well, today, you and I are going to play a very common game. You know, the kind of game where there's a picture and they have trees and bushes and houses and whatnot, and you have to sort of look in the little leaves and the bushes to try to find a face or a figure or squirrels or animals or something like that.
Things.
Well, that's what the kind of game we're going to play today. And instead of having bushes and a house and trees and things like that, we're going to have all these things I've collected here. So let's see if, first of all, you recognize what they are. You recognize this, I assume?
Yeah, it's a record player.
Yeah, it's a record player. And you recognize what that is?
I think it's a little motor, isn't it?
Yes, a little motor and a little gearbox over there, so that's another thing. You know this...
That's a speaker.
Yes, and that?
A spoon.
Spoon.
Funnel.
Yes, and down here is a little cap from a spray can.
What's in there? Something.
Well, some white powder, yes. Okay.
Okay.
And
Slide projector.
slide projector. You know what that is?
Static generator.
And this.
Balloon. What's that?
I think we used those once before, didn't we?
Oh, it's a photo cell, isn't it? A light cell?
Yes, when light falls on it, why it generates electricity, yes. And there's a little motor.
Motor, yeah.
And down here is a hinge, see it?
Yeah.
And then there's a wire that goes across here, and over here is a motor.
Bicycle wheel.
Yes, a bicycle wheel. And on the other side,
Something else.
looks like another motor, doesn't it?
Yeah, a little bit like one.
Okay. And then more wires come over here, and we finally go up to this. You know what that is?
Oh, yeah, that's from a train set.
Yes, a train set. And you want to go around and you look on the other side. You'll see what I have over there. See it?
It's a mousetrap.
Yes, a mouse trap. And that's got a string on it going up here. And right up there is a little thing from the end of a medicine dropper.
Oh.
On the end of this tube. And you recognize this?
That's from a lamp, isn't it?
Yes, from a lamp. And here?
That's for distilling things.
It's a condenser, yes.
Oh.
And then here, you recognize these?
I don't know. There are two wires.
Yeah, two wires and a pitcher.
Uh-huh.
Well, there are all the everyday things that you are, that you're going to have to find the hidden things.
What am I looking for?
Well, what you're looking for are 6 different ways to make electricity.
Oh, that's easy.
Hidden in all of these things are 6 different ways. They may not be so easy.
Well, we have one right there with the
right
wires.
there. All right. Well, now, wait a minute. I have a pencil.
Yeah.
Here you are. And here's pad. Can you tell me 6 different ways to make electricity?
I think I know 4.
All right.
Well, there's light,
Yes.
and there's sound.
Oh, wait a minute. Wait. What do you mean by sound?
Vibration. You know, when you speak into something and then it's...
Oh, into a microphone, a little electric... Oh, I see. Well, now, wait a minute. All you're doing there is you're changing the vibrations of your voice into an electrical signal, but I want to know what is it that changes it? Where do the little electrons that come out of the microphone come from?
Gadget.
SO, cross off. Okay.
Okay, SO's off.
Light, you understand? There's something inside
yeah.
that does it. All right.
Heat.
Heat, okay.
H-E-A-T.
Yes. You said you knew
Motion.
4. Well, now, what do you mean by motion?
Well, say you're turning something, and that,
Well,
say
what-
the
what
field
is-
radio, and then it's...
Oh, yes, but when they crank the field radio, what is it that they're turning? You know what's inside?
Magnet.
Magnets and coils, yes. So if you put down magnetism would really be there.
All right.
Okay?
Magnet.
Net.
Good.
That's 3. 3 more to go.
Give me a clue.
You have rugs in your house.
Yeah. Oh. Static.
Yeah, static.
Okay.
All right.
That's 4. 2 more?
Mm-hmm.
Sure?
Mm-hmm.
And they're in there.
And they're in here, yeah. All right, another clue then, I suppose. Well, I'll make it easy. Flashlight.
Battery.
Yes. Well, where do the energy come from, or the electrons come from in a battery? What kind of a...
Oh, well, you have the different chemicals and
Yes,
things.
chemicals.
Huh. Not as stupid as I look, huh?
One more.
Can't make
And just write down piezo. P-I-E-Z-O.
Goes on height.
Yes.
P-I-E-Z-O.
I-E-Z-O. That means pressure. That you can get electricity from creating pressure on certain types of crystals.
You can?
Yes. Okay, now you thought of 4 fairly well, and then you had trouble with, or really 3. You didn't really get the magnitude, although you did know it was turning.
Yeah.
Let's see examples of each one of these.
Okay.
Now, before we go look at the, see if you can find them hidden in the, in this. Oh, there's one right there that
Yeah,
you were just
balloons.
bumping into. How do the electrons get on the balloons?
Well, you have to rub it with something. Shh.
And
Noisy.
you're rubbing electrons off of the wool onto the balloon.
Uh-huh.
And how do you know?
Because when you do it to both, they keep away from each other because
Yes. So
they're repelling each other.
that's example number 1. So you're going to see if you can find this example when we look at the hidden ones over there. Okay? That's number 1. Any idea what that is now?
Battery?
Yes, a little battery. In there, you know what's kind of liquid is usually in a battery?
Acid, I think.
Usually acids. You can have other kinds too. And what are these 2 things?
Well, I guess one would be copper and the other,
This is zinc.
carbon.
Carbon and
And
zinc,
zinc.
yes. And when you put them in here, and I have to give it a little touch to get it going.
Phone's ringing.
Phone's ringing. And to prove that it's actually coming from there, you can see when you take it out. But I
Right.
don't have it just strong enough to get it first thing started, so I have to touch it. So that's static, chemical.
Chemical. Okay.
Now these are all clues, see, because later on when you look at them, when you look in where they're hidden, well, you should be able to try to identify the actual thing, right? Okay. What's that one?
Do I turn this?
Yeah, turn it.
Oh, the light goes on. That must be a magnet.
Well, in this case, the magnets are stationary, though, aren't they? Here, let me pull them off. And you see right down in here. You see when I turn it slowly?
Yeah.
There, right in there, there are a whole pile of little tiny wires coiled in. See them there?
Oh, yeah.
And then the other side of them is, on the other side over here. So as you spin that coil, you see you're spinning them inside the magnetic field of these 3 magnets.
Wasn't that Faraday's discovery?
That's right.
I
He
think?
moved a magnet near a wire and found that there was electric current there. And so what do you call this kind?
That would be the magnet.
Magnetism. And this is called a generator.
Yeah. Pretty good.
All right. Now you want to go around the other side of there so you can see those meters. Because here are the last 3. We've got static, chemical, and magnetic. Now you see this little thing? Now look at the meter. What happens to it?
It went up.
Okay, now put your hand over here.
Went down.
Yes. So what do you think that
That must be the light.
yeah.
The thing for the light.
Sure it isn't the heat of your hand?
I don't think so.
No? Hold your hand way up once. And then gradually bring it closer. Try this. Definitely light.
Definitely.
Okay.
Very good.
Now, in here is a special little kind of metal that when light hits it, it kicks out a little supply of electrons, and they go down through the wire and are making the needle move here.
Oh.
All right? Like, all right, so that's light.
That was
So we
so
have
hard.
static, chemical, magnetic, light, and now what's this one?
Well, it's going to be heat.
I think so, because there's a candle there.
Yeah.
See these 2 little wires?
Yeah.
Little tiny wires, how they're twisted together at the end.
Oh, what are they?
Well, they're iron and constantan, 2 dissimilar metals, and when you heat them up, electrons flow out of one, go all the way around, run the meter, and go back on the other if it's due to heat. Watch.
There it goes.
Yeah, see it go? And notice the hotter it gets, when I move it right into the flame, why
Yes.
the more the needle moves,
Yeah.
when I pull it up now gradually...
It goes down.
Yes. That should give you a clue later to some questions I'm going to ask. Remember that.
Okay.
The hotter it gets, the higher the needle moves.
Right.
All right.
That's 5, right?
That's 5. Do you remember that word I told you about?
Piezo?
Piezo, yes.
Piezo.
Well, the dictionary says piezo, it is P-I-E, but I have some Italian friends and some Greek friends and some engineering friends, and they all say piezo, so that's the way I'm going to say it.
Okay.
And here it is right here. You probably don't recognize that.
It looks like a piece of glass.
Yeah, it looks like a piece of broken glass, doesn't it? But it's a crystal of Rochelle salt.
It's a paperweight.
Yes. And if you twist Rochelle salt or some other types of Rochelle salt crystal, and some other types of crystals too, you get a feeble electric current. The crystal itself, as you twist it, sends out little electrons, and they flow through the wire. And this was not really the way it's meant to be done, but I just put some plates on each side, and I'm going to try to squeeze it, and you see if you can see the needle move just the tiniest little bit. Now watch. See it move?
Yeah, it's moving a little,
tiniest
just a little bit.
Of course, this is not the way they use it, but I don't want to give you any more of a clue because I think maybe I might be able to catch you on this one. Just the tiniest little bit. So there we have the 5 different ways. Or 6.
6, yeah.
Okay, now I'll go through and explain what this is. I didn't explain what it was. Because instead of a picture of a house or something, what that is an automatic volume control. Come, let me show you my automatic volume control and see if now, while I'm explaining it to you, you look around for those 6 hidden ways to make electricity, but do not tell me until we're all finished.
Okay.
Okay, because there's only one of each, so you should make sure that if you guess one, that later on there won't be another one and that you might want to change your mind.
Oh,
there's only one of each kind. Now let me explain.
Not fair.
Let me explain how my automatic volume control works. You put the needle on the record here, see?
Yeah.
And when it comes to a loud passage, the current is going to vibrate this speaker. Now the speaker cone goes up and down, and when it gets to a very loud passage, which is where the volume would be, why then it's going to vibrate this spoon more and more until finally it dumps the spoon over. And in the spoon later on I'm going to put some water. So that means water is going down this funnel and will drip down here into this little can cover or a spray can cover. Now, inside there I have 2 chemicals, and when the water gets on it they'll start a chemical reaction and create heat. Notice these 2 little wires here?
Yeah.
Well, they're going to sense that heat, send a current over to here, around over here, and after a slight delay, I didn't want it to go too fast, it's going to turn on this slide projector. The slide projector, of course, is going to shine this direction over here, but you notice that the balloon is in the way.
Yeah.
Then another delay in here until when this starts turning around, and creating a static charge, what'll happen to the balloon?
Move away.
Yes, the balloon will move away, and what'll happen to the light?
We'll hit the cell.
Yes, the balloon will be able to go by the space between the static generator and the balloon and hit this photocell.
You gotta be putting me on with all this stuff.
No, this is
you do.
in fact, I meant to tell you that I've been explaining these in ordinary terms, but they have much more serious terms too. For instance, the water in the speaker over there is known as speaker dampening. Well,
okay.
And this is a filament, isn't it?
Yeah.
Yes, and here's a plate over here.
Yeah.
And here's the grid, you see? Like in a vacuum tube.
Okay.
Okay? And here's the motor. So when the light hits this cell, it's going to start the motor turning. And see, there's a little tiny thread that'll be wound up here. And as that thread gets higher and higher and higher, it's finally going to pull up on this hinge. And as it pulls up on the hinge, it's going to close a contact right there.
Oh.
So that'll allow current to flow through this wire over here.
Yeah.
Be careful. That will start this motor. Now this may look like a bicycle wheel to you, but it's really a cyclotron.
This is ridiculous. That's a bicycle wheel.
A cyclotron, isn't it? Okay. Anyway, you start the motor. When the motor starts. There'll be a slight delay again. As it goes around, it'll go round, around, around, and when it comes around over on this side, it's going to make that little wheels spin. You see that has little ridges in it.
Yeah.
So the bicycle tire it will grab onto the bicycle tire and it'll spin around. So a little current will come out of there, go around here, come down here through another little sort of delay system I have down below. When it comes up here to the railroad signal, inside there is a little coil with a plunger in it, and as the current goes through it, the coil is pulled down into it, which will pull down the railroad signal. Okay. Now then, there's a little thread connected through a hole over here to the mousetrap. So when the signal goes down, the mousetrap will spring.
Now that may be a cyclotron, but that's a mousetrap.
Okay, but it's part of it. When I finish, you'll see it's part of a very, very interesting electronic device. Because when the mousetrap flips over this way, it's going to pull on that string, and you see that string is attached to the back here of this medicine dropper, which is put on this tube?
Yeah.
Well, that's going to pull the medicine dropper top off, so air can get in there. So here's a three-stage amplifier, you see?
1, 2, 3.
You don't think that that's true? Inside here, Right here is a clamp, which I will now open.
Okay. Well, yeah, it's running down.
Well, a little bit is going to run down there, but why doesn't any more come out?
Oh, it's a vacuum.
Yes, because as the liquid starts down, this air gets quite thin in here, doesn't it? You know, it gets stretched out, so that's a vacuum tube.
It's not a lantern anymore.
No, it's not a lantern anymore, it's a vacuum tube. So now, when this top of this medicine dropper is pulled off here, air can get in there. Pushes down on top of the liquid, and the liquid now can run down this trickler coil.
Uh-huh.
See?
Okay.
And when it gets down into here, it'll now gradually fill up into this thing, and you will now have two electrodes,
Yes.
zinc and carbon, and that will generate a little current. And that little current goes along this wire, and now if you come with me, we'll follow what happens to the wire.
Don't they have all of this in one little
Yes,
thing
they
about
do.
the size of a fist in a regular record player?
That's right, they do have an automatic, but you see what happens to the wire?
Comes back.
Over here to this motor.
Well, what's that do?
Well, the motor is connected to here to this gearbox, and that gearbox has a little pulley on it, and that pulls up on this string. So as it pulls up on the string, it finally lifts the arm off the record player. So there it
Pretty
is.
good.
There's my automatic volume control.
Does it work?
Well, we'll find out. We'll do it before you leave.
Okay.
But now, as I went through these, did you find the 6 different ways of making electricity?
I found some of them.
Okay. So
No.
go along. Record player, motor,
No, not really.
speaker.
No. With the chemical, you know, the thing when it goes on fire,
Yes.
that could be heat, couldn't
Yes.
it?
Yes. You could call that. These are the 2 little dissimilar wires I told you about
Right.
before. So that'll generate a little feeble current there. So there's number 1.
Heat.
Okay, heat.
Well, that's light, of course.
Well, but you're not going to make the electricity's not going to come out of this light.
Well, you have static here.
Okay, that's static. And you know there's one kind of pulley at the bottom and another one on top, and they're dissimilar. And as it spins around, why it rubs on a piece of wool, and creates a static charge, and out goes the thing. Okay, so that's 2.
Then
Heat
the
and
light will
static.
hit here.
Right. It's here. So that's light.
That's light. So
That
that's
sends out a feeble current to run the motor. So that's 3.
3. Yeah.
3.
Doing pretty good, huh?
Yes. Yes. You
Okay.
have 3 more to go.
Well, that's a motor. That could be the magnet, couldn't it? You know, an electromagnet.
Well, it is true. There are some motors have magnets in them, but what happens there? The electricity goes into the motor and spins it. You got to find something that spins magnets or coils and gets the electricity out.
Oh.
So it's the opposite of a motor.
Well, what about this? That could have a magnet, is it?
Yes, and you could see if the motor makes the bicycle wheel spin, when you spin it, there could be magnets in here.
And that could-
In fact, I thought you'd recognize that one. Don't you have one of those on your bike? Is it for?
No,
is it-
I used a little battery.
Oh, well, this is a bicycle generator, and you can hook this to your
Oh.
bicycle, and it spins inside are magnets and coils that spin around, and it sends out a little current. So that's right. You were correct.
That's 4.
That's 4. That's a generator, the magnets. All right.
Okay, 2 to go.
2 to go.
Let's see. Nothing there with that 3-stage.
How about that little coil inside? That's a
I don't
solenoid.
think so.
Okay, I won't confuse the issue. Nothing in the mousetrap, you sure?
Yeah, I'm pretty sure.
You know, nothing up here.
No, this could be the chemical because it comes down, forms
Right.
a battery.
Okay, so that's chemical. That's 5.
It's fine.
You've got heat, light, static, magnetic, and chemical, and the piezo or pressure one is left.
Yeah, what happened to that one?
Well,
We
let's
lost
follow
it.
it back. Here, remember the wire went all the way
Where'd it go?
across. Over here.
Right back to where we started.
Yeah, right back to where we started. See, I missed one.
Yeah.
Well, you're looking at it.
The record player?
Yes, you see the needle?
There's no pressure there.
Well, now wait a minute. When you put the needle on the record and the needle vibrates back and forth, inside there is a crystal in a little cartridge.
Oh.
And as it vibrates back and forth, it sends out a feeble little current to the amplifier, and that's how you...
That wasn't fair.
Why not?
You should have warned me.
Yeah?
You know, that was the harder one.
Now, wait. Oh, I forgot your list. Let me check. Stay here. I'll get the list, and you see if you can get them all.
Okay.
You got them all now? Let's make
I
sure.
think so. I have light.
You got the light. That was the record player, or that thing over there.
Yeah, the
Heat
heat.
was this one here. All right.
The magnet was the generator.
Generator. Okay.
The static was
Static.
the static generator.
The static generator with the balloon. The chemical.
Chemical was the battery.
Yes, the battery over there.
And that was the record
The
player.
record player. Okay. Well, now we're about ready to go with the thing, but before we set it off, I wondered if you could tell me examples of the various ways that these kinds of electricity are not these kinds, but these sources of electricity are used right in your house.
Well,
You know, I have all kinds of fancy gadgets here to do it, but you use these around the house in various ways. How about light? Can you think of any way where you use light as a source of electricity around the house?
well, let's see.
What if you want to take a picture in here? Could you do it?
Oh, if you had enough light, yeah.
Yeah, how do you know if you got enough light?
Meter.
Yes, the little meter needle moves, right? And that's
Yeah.
because of electricity. How about heat?
What about in those ovens? They have the new ovens with the heat. They cook.
Oh, you're thinking of the infrared where it shines down. No, in that case, you're talking about electromagnetic waves, but it's not electrons flowing through something. Do you remember those two little wires that are there?
Yeah.
Well, sometimes they have those inside the oven, and they lead the wires off to a meter. Remember I told you over there that was a clue that the hotter it
Oh,
got,
yeah.
the more the needle moved? You can make a thermometer.
Yeah.
And that's about the only place around the house there might be heat change into electricity. How about magnets? Where do you spin a magnet around the house?
Magnet.
Yeah. Other than a bike generator.
Yeah. Well, let's see.
Give you a clue. The garage.
Car?
Yes.
Yeah.
Is there a generator in a car?
Yeah.
What do they use the generator for?
Well, keeps the battery going.
Well, it keeps the battery charged, and then they run lights and radios and things like that. Sure. So that's a magnet. How about static? That's going to be tricky.
Oh, I don't know if you want a shock. Just
No, I'm talking about a useful purpose. Unless you're talking about your sister.
Yeah. Give her
No,
a
I'm
shock.
talking about a useful purpose. That static electricity is used around the house. All right, another clue?
Yeah. Another.
Sandwiches.
Oh, I know. You have to that thin plastic stuff.
Yes, that you wrap around sandwiches.
There.
And the reason it holds together is because of a static charge on it. Yeah.
But they're sticky. They get all over your hands.
Yes, because of the static charge. So that's where that's used. How about chemical?
Battery.
Yes, batteries and flashlights and all. And the piezo, of course, you.
A record player.
Yeah, a record player. All right. Are we ready to go?
Well, I guess so.
All right. Well, let me check. First thing I have to do is add a little dampening to the speaker. Okay. Now make sure the wires are down in here, and so they get nice and hot. And light.
Will it work?
All right.
Is it gonna work? Let's
First
see.
of all, I want to turn the volume down. I'll turn on the record player, and I'll see if I can get this positioned at just the right spot so I don't get too much noise right away. And we'll give it a try. Okay, are you ready?
Yep.
Okay. Watch this. Not too loud yet, all right?
No. It's not moving very much.
Okay, it'll get louder in a minute. I just. Watch that spoon.
More.
All right.
Okay. What's happening?
Well, there goes the flame. How about the light to go on?
Yeah, why not?
Light went on. Now there's a little delay built in here.
Whatever that cat.
Really blew up the cat,
Yeah.
didn't it? And certainly plenty of heat there to keep the light going. All right, let's see if this is going to work. There it goes. Come on, blown up.
Up.
Come on, balloon, up. It's twisted around. There it goes. Okay, come on, balloon, up.
Thread's moving.
Okay, this is winding up.
Yeah?
Is that going to start it? Ow! I'm getting a shock from the static there. There it goes.
There's
This
the...
is starting. There's a slight delay built in here. Oh, there, right there. Oh, here it goes. Is this working?
Yeah, it's going down.
Okay, there.
It's going up.
Okay, now we should trace the line back because as soon as that fills up over here, this ought to work. So let's go back and look at this, see if this starts. There it goes. It's working.
Yeah.
Aha! It worked.
It worked.
Congratulate me. I'm surprised. Just a minute. Let me turn off.
What are you gonna do for an encore?
Well, it takes you about 2 hours to set the whole thing up, so I'm not going to do anything for an encore. But you see, most of it worked. I had to give a little help for everything.
Yeah.
All right, now. Okay, well, now you found them all, didn't you?
Yes.
Now that they all worked and you saw they really worked, this one was what?
Piezo.
Piezo, yes.
Heat.
And this is what's left of
Boy.
it. Yeah. The heat.
Yeah.
Okay. This one, light.
Light with that.
And this?
Static.
Yeah, here's where the light really
Yeah.
was, yes. Over here is the motor over here. Okay, and then over here was this one.
Magnet.
Right, magnet. And up to
So
here.
Chemical.
Yeah, you sure there wasn't any in here? It was only the
Yeah.
chemical over here.
Right.
And the chemical went back over to the piezoelectric. So you see, there were all 6 methods of making electricity. And which of all of them do you think is the most important?
Well, I would think the chemical and the magnet.
Yes, of all the various ways of making electricity around the house, chemical is important because you use it in a car and you use it in flashlights and and things like that. And in modern days, they have very little tiny batteries and hearing aids and and photocells and all sorts of things. But probably the most important one is this little generator right here because they have great big huge ones, and all the light in this room and all the lights that you see come from generators like this little one here on the bicycle.
Watch Mr. Wizard. That's what all the kids in the neighborhood call him because he shows them the magic and mystery of science in everyday living.
Mr. Wizard!
Hi, Alan. Come on in.
Hi, Mr. Wizard.
Hi, come on over here and meet my friend.
Hi, friend. A cockroach.
Yeah.
What kind of friends do you have?
Well, he's a friend because today you and I are going to study how animals move, and later on we'll look at him because there are a lot more similarities between you and how you move and a cockroach move than you think.
Well, we're very small, you see.
Yeah.
We're very small.
First of all, let's start with the beginning, kind of the basic science of how animals move. For example, when you walk across the floor, one of the first principles involved is action and reaction. How does that apply to you?
Well, when you're walking, there's friction between your foot and the floor, or whatever you're walking on.
Yeah.
And as you're moving ahead, you're pushing back against the floor, and if the floor could move, then it would move backwards.
See? How much energy do you really think, or how much force do you have to exert with your foot when you move forward?
Well, not much.
Doesn't seem like much, and it doesn't.
No.
Well, let's measure it. Let's actually measure how much energy or how much force you have to apply to move forward.
Well, how are we going to do that?
Well, over here. See, this platform down here in the floor is on these rods, so it'll roll. See?
Uh-huh.
Now, if you stand here with 2 feet and then you take a step forward, this foot's going to have to push back, isn't it?
Yeah, it'll push the board
It'll
back.
push the board back. Now the board has a piece of wood back here, so it'll hit this metal rod,
Yeah.
and that metal rod is a plunger of a scale.
Oh, I see.
See, and I have a
That's
weight on the
scale.
floor, so the scale won't move. Now see that right? I'll push back on the board a little bit. See the rider move down with the
Yeah.
scale?
And it stays there, and it registers the amount of pounds.
Number of pounds of force that it'll take for you to exert as you take one single little step. Now I want you to be careful when you step on this because it's very, it's very rolly.
Yeah,
And
like a flying.
so you carefully step with both feet on there.
I'll push
Oh yes,
back.
push that back. Okay. Step with both feet.
All right. Let's see.
Not on my fingers, thank you. All right. Now I'll get it so it's just exactly touching. I'll zero the rider, and now, don't jump. But on the other hand, don't take a soft step because you feel it's. Try to take as normal a step as you can and move forward, and we'll see how much force it takes. Go ahead. Well, what does it say?
Wow, 15 pounds.
Yes.
Gee, I didn't know it was that much.
It's quite a bit of force, isn't
Yeah.
it?
I thought it was just, at the most, a couple of pounds.
Couple of pounds. Well, now there's many inaccuracies in this method of measuring.
Well-
However, it does give you an indication that there's a lot more than you thought.
Uh-huh.
And so, now is this same thing true with other animals as they move across?
Yes. They all apply pressure. Maybe not the same amount.
No, they certainly don't. And they also apply it again, pushing against different things. For example, a fish against water,
Water.
a bird against air, and so
Air.
forth. And a cockroach against a white ball.
Oh,
See? And that's why I was looking at my friend the cockroach. Because he's kind of doing the same thing. He's on a little treadmill, isn't he?
yeah,
And
little
not-
styrofoam
And notice
ball.
how strong he is to be able to,
Has to be to hold
yeah,
up
to
that
hold the ball.
ball.
Now I'll give him a little puff of air here. Come on, move.
Oh, he doesn't like that. There he goes. He's not moving very much, but the ball
Yeah,
is.
the ball is. All right, now come on, move.
There he goes.
Oh, too much. I think he jumped. You see, he was trying to jump to something,
Yeah.
and
He dropped the ball.
yeah.
Catch.
So you could actually use this to time how much or to measure how much force it takes to move by figuring out the mass of the ball and making some calculations. But the same thing is true with a little cockroach as it is with you. I told you they were the same. You see
Yeah.
that you both have to push against something.
Well, he doesn't
in order to
apply
move.
12 pounds or 15 pounds, whatever it was.
Well, now let's put him down. I'll put him back in the box and I'll get him cut his string off later.
Go back home.
Go back home, yes. I'll keep the stick on him so he can't go flying away. I don't think my wife would like him loose.
I don't think so either.
No, so I'll put him in there. Well, now, that's pretty easy, just figuring action
Yeah.
and reaction. But now, the more important part of the thing that we're going to study, at least, is what is the leg sequence when animals walk?
Oh,
Now, let's start with the simplest number of legs.
well, that would be 2.
What animal do you know of that has 2 legs?
Well, we have 2.
Yes. Well, now, I would like to see if you could figure out the proper sequence when you walk from here over to there. Tell me the proper sequence of legs.
Gee, that's hard.
What is it?
One after the other.
One, left, right, right, left, whichever one you started with. Actually, though, however, that's a little more complex than you thought. Actually, the sequence is quite simple. But what happens is really, what you do is if you stand on one leg,
Yeah.
you have to bring, and you're going to move to the other leg like this, you now bring that leg that's back over here and move it forward so that it's like wheels of a spoke.
Yeah.
And
Just
when,
like it.
Yeah, and when an
One at
engineer
back
has
from
to
the
solve
front.
when an engineer has to solve this problem, well, he uses spokes because it's hard to make this leg move forward. In fact, whenever they have mechanical man or toys that move, notice that
on
walk.
wheels.
Well, either they're on wheels or if they do actually make the legs move. Remember, it's very mechanical.
Yeah.
It's very difficult to solve that kind of problem. So that your simply sequence of one leg going in front of the other is really a very complex thing. You think it's very simple, just left, right, but I'll have to turn that leg over there.
There we go.
And every once in a while, a friend of mine comes along and does like that. It kind of confuses the issue.
Confused person.
So that, while the sequence is relatively simple, the action is a very complex one. How about the next number of legs? Any 3-legged animals?
No, 4.
4.
Uh-huh.
Okay. Well, now, that complex movement, if this was complex,
what sequence does, let's say, a horse move as it tries to move across the ground? It has 4 legs. It's not just one in front of the other, is it?
No, it has 2 pair of legs. So, well, we move 1, 2, 1, 2. So I imagine it would go. And
One,
then this
two.
is the back one.
Yeah.
And then the other back one.
Well, now, you know, you're kind of guessing at it. Yet you see that book over there?
Yeah.
A long time ago, in fact, this is a reprint of the original book, a man studied the motion. He did a great number of studies of the motion of horses and other animals, too. There's an ostrich.
Yeah.
See, and buffalo, deer, and
monkeys,
and then he did a
lions.
great number of horses. The first half of the book practically is nothing but the way horses move when they run, gallop, and walk, and so forth. So this was a marvelous work because it's called Animals in Motion and was done a long time ago before they had a lot of the tricky photography that they have today. And here's probably the best sequence of a workhorse walking. Now,
There it is. Is it walking here? Or it
well,
doesn't
it's
look like
beginning here. Let's take, say, this group right here.
Okay.
This 4 legs. Notice the 2 legs in the middle are the ones he's standing on, and the 2
Yeah.
outside legs are moving. And notice which the 2 legs are that he's standing on.
Well, over here, they're diagonal. One is on the
Front
right,
right
side,
and the left
the other
rear.
is left
Okay,
rear.
then he keeps walking along. Now now take this one down here, for example.
Well, now it's
The 2
different.
outside legs
Yeah,
are supporting
two
him.
outside legs.
And notice which the supporting legs are.
The left front and rear.
They're both on the same,
Same
side.
side.
So that the 4-legged movement of a horse is not easy to
No.
follow. But maybe we can do it best if you take 2 legs
Oh,
and I'll
okay.
take 2 legs.
Which side should I be?
Well, now we're going to do front and back, so
Yeah.
take your choice.
Front.
Okay, I'll be the back.
Okay.
Let's say he's going in that direction because you're the
Okay.
front, okay? Now, let's
First-
both pick up the right one. See? Now, what happens with the horse is that I change, the back end changes first, now you change the front end.
Well, it'd be that way. wouldn't
Yeah, and then I'll change the back. Sounds like a horse.
Yeah. So at one time.
So at one time, the 2 legs on one side are supporting him, and then the diagonal legs are
Yeah.
supporting him. So it shifts back and forth. So it's a little more complex than just kind of
Yeah,
2 pairs of
it's
legs
not-
walking.
What I thought it was.
Yeah, it's much more complicated.
Okay, well now that's for a 4-legged animal, and many 4-legged animals, cat, dog, you know, all the rest of them, use that same sort of sequence. Now, what's the next number of legs? 5?
6.
6? What kind of an animal is that?
An insect.
All right, let's go look at an insect, and one that has a beautiful walk. And he's a very good friend of mine. I want you to treat him very carefully.
All right. Not the cockroach.
No, not the cockroach. He goes too fast for us to study. But this is a very good friend of mine that you
Isn't
know
that
what
a
he
praying
is?
mantis?
Yes, a praying mantis.
It's
Come
a
on.
$50 fine to kill them.
Well, they're very helpful, as you know, because they eat other insects.
Mm-hmm.
Now, let's put him down here on the table and see if he'll walk. And I want you, come on, now that's it.
Here he goes.
Now, what's the sequence of legs?
Well, it looks like. No, he stopped.
See,
Can't
he's looking around at you. See how he looks?
Why?
This is one of the very, very interesting insects because he can turn his head like that.
Yeah, there you go. Just like
You heard me saying something, it looks like, didn't you?
Oh,
Now,
he
you
seems
see,
very smart.
he's now standing on only 4 legs, notice, because he
Yeah.
has the front 2 are used as grasping organs to grasp insects, and he uses them to eat, and it's very interesting to watch him do it. Come on, now, let's not stand around. Let's walk.
Walk. Move.
Well, put your hand down, because he likes to crawl over there. See? Come on. That's it. There's my friend Alan.
Come on.
Come and walk on for Alan.
You know. Come on.
Let him touch it, maybe he'll. There he
There.
goes. Now, see if you can notice his walking movements now.
Looks like he's pushing up from the back. First the back one, and then the other back one. I think. Wait a minute. Now he stopped.
Come on, now move a little bit. That's it.
1, 2, 3. No, wait a minute. He does 2 at a time. These 2, and then these 2.
Yes.
Hello.
Yeah, get your other hand.
Yeah.
They're kind of interesting insects because they don't seem to be afraid of you, do they? They just walk right up. In fact, he's going to touch you on the nose. So the sequence of a 6-legged animal, is a little more complex. But now let's put him back. Are you ready? Okay, thank you.
Got him?
Yeah, I got him.
Very friendly.
Onto your little screen. Keep going. And now we can turn him upside down. There he goes. After 6 legs, what's next?
8, I think.
All right, what's an eight-legged animal?
A spider.
Come,
Oh,
do you
something
remember Evelyn?
The tarantula?
Yes.
Yeah.
Well, she was busy, so I couldn't get her. But I have a new one for you to meet, Blondie.
Oh,
Come
yeah.
and meet Blondie. Oh, now wait till I get her. She's very anxious to get out. I think
Yeah.
she's anxious to meet you.
Another tarantula.
Another tarantula.
Her legs caught there.
Well, here, I'll put her down here and see if I can straighten her out. Here. Come put your little leg
She's
up there.
friendly as Evelyn was?
Well, yes. This is one of Miss Gray's pets. Miss Gray is one of the insect expert at the American Museum of Natural History, and she has several of these. And she let me use them so I could show you what happens when a spider walks.
He looks like she has 10 legs. Looks like it, anyway.
Well, those front two are really feelers, you know, antennae, and
Oh.
she pushes them down and feels of the ground, but she's not really using them to walk. All right, now let's not get so close to the edge there.
Yeah.
Come back. I don't think Miss Gray would like you to go off in different directions. Now, see if I'll try to get her to walk a minute, and you watch the sequence of legs. Now, come on, that's it. Keep going. Keep going.
Looks like they alternate. First the back two and the front two, and then the middle ones. No, first the back ones and the ones next to the front. and then
Lips,
the
come back.
ones-
Excuse me a minute. She's looking over the edge of the table. Now, back around.
Nothing's down there except
All right.
a long fall.
Yeah, come on back here. And let's have her try walking again. Now, what were you saying?
It looks like first the back two, and the
Notice she's very gentle.
yeah, and the ones that are next to the front two, not the front two though.
Mhm.
And then after those move, then the ones next to the back.
First
two,
these, then those, then
then
those,
then those.
So,
Alternating.
You see how complex it is, though?
Yeah. It's almost like
and,
4 at a time.
And not only that, but she of course can move sideways too, and some spiders of course go much faster than
Mm-hmm.
Blondie. She's very tame. Blondie, you want to walk over this way? Come
Yeah,
back.
Blondie.
Anyway, now you've met both of Miss Gray's pet spiders, the Blondie and Evelyn.
Mm-hmm.
All right, Blondie. Get back in. That's
Back
it,
in.
girl.
That's it.
Oops.
Whoa,
Get your feet back in
watch
there.
Your feet, watch
There
your
we
feet.
go.
Here, why don't you sit down? Because
Thank you.
we now have a bunch of the next number of legs right over here in a group of boxes. After 8, what's next?
Well, I guess. Wait a minute, centipede, wouldn't it be? Centipede?
Well, actually, there's one kind of in the middle. It's kind of an interesting animal because it has 6 legs and is an insect, but in this particular stage, it has some temporary legs.
Oh, a caterpillar.
A caterpillar, yes. Now, I got these from Mr. VR. He's a breeder of very exotic butterflies, and he takes photographs of them. And he said that this one was just about ready to spin a cocoon.
Oh.
So he thought it might be a little sluggish, and it's kind of late for them. But you see the little feet on the back?
Yeah, let's see. 1, 2, 3, 5.
And then there are 3 feet
Three
up in
small-
front,
yeah,
3
but-
little tiny ones.
Yeah, they're smaller than the others.
Well, those 3 little feet in the front are the true legs, and these legs in the back here are temporary legs that it has only when it's a caterpillar.
Oh, then they'll
Come on
lose
now,
the
come on.
back ones.
That's it, move. Come on, can you move a little bit? Come on, move. Whoop!
Whoa.
Now I tickle him in these hairs on the side here. Come on now. Oh, he didn't like that. Come on, get going. Come on, get going, get going.
There he goes, there he
Yeah.
goes.
Now see the way his little feet work?
Yeah,
Kind of a ripple.
it's pushing up from the back.
See that? Keep going.
His feet are like little suction
Mm.
cups.
Well, you see, they're adapted to hang on a branch like this, you see? So he can stand there and chew
Yeah.
away on all the leaves. And he said that this one will spin a cocoon, and then you put them in the refrigerator and take them out, in 4 or 5 months. And then he'll come out into a beautiful butterfly.
Hmm.
Anyway, there's kind of an interesting animal
Yeah.
because of that strange legs that it has only part of the time.
And then the 3 that are true legs,
And-
which are much smaller.
And various caterpillars have various numbers of legs. You know, they don't all have the same number.
Mm-hmm.
Okay, you want to go back? There's some little lettuce in there for him to eat in case he doesn't want to spin a cocoon yet.
After the prolix of the caterpillar, what's next?
Well, then I think would come the centipede.
The centipede, huh? Well, Miss Gray had a fabulous centipede. Wait till you see him.
Wow.
Isn't that a beauty?
Gee.
This is one that you just got in from Arizona.
Which is the front?
Well, see the antenna, how he moves them all around?
Yeah.
So that's the front end.
Uh-huh. This end right here.
Yes. And one of the ways you can tell a centipede from other many-legged animals is that the centipedes have one pair of legs for each segment. You see?
Oh,
For
yeah.
each segment. How many legs does he have?
Let's see. It's 1, 2, hold still. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that would be 38.
38, yeah, 38 legs. And look, think of what of the nervous system that there must be to control all
those legs. 38
And now,
legs.
can you see that he moves in somewhat the same way that the other insects did, in that the movement sort of flows in the opposite direction as he's moving. Watch now.
Yeah, it pushes up from the back also.
Yeah.
Boy, he's really
Isn't that something?
growing, isn't he?
He's poisonous too, so I don't want to take him out of the box.
Oh.
He said there's a slight poison in the back, and she also said he's a very fast-moving one.
Where's
So-
he come from?
From Arizona. Yeah. So he's, well, after, and by the way, I made some notes on the number of legs. Centipedes have 15 to 173 pair.
Oh, brother.
So it depends on the species and how old, because as they get new segments, they add a pair of legs each time.
Yeah.
How about the next one? What's after that?
Millipede.
One millipede coming up. This one was a very rare specimen, according to Miss Gray, and he said it was getting kind of sluggish and kind of old, and she didn't know how long he was going to last. But let's get him out. He's curled up in a ball here at the moment.
Where does he come from?
Come out, fella. I think she said this one was from South America. There he is, all curled up in a ball. Now let's see if we can.
Looks like a snake.
Yeah, well, let's see. Wait, we can wake him up now. Come on, come on.
Yoo-hoo.
His head is in the middle there, and we'll see if we can kind of stretch him out and make him see if he can find someplace. Now, come on, straighten out there. There, you see? See that little antenna?
Yeah. Uh-huh.
Okay, now move. Move.
Move.
Come on. Come on. I just told you can't stay curled up. Don't blow on him.
Oh.
I think he might be a little cold, and so he's trying to stay warm. Now he's backing up.
Here he goes. For a second.
See if I can straighten his head out here now. Come on, now. You can't curl up in a ball. Go straight. Go straight. Just let him sit there for a minute. There he is. No antenna now going. Now watch
There
what
he
happens.
goes.
Now watch what happens as he moves. Oh, he's going to come back this way. Watch.
It's pushing up from the back also.
Now watch him as he goes over the edge. Come on, now go over the edge. I haven't thought of a good name for him. How about Ralph? Wouldn't that be a good name?
Great.
Yeah, that's a good name. We'll call
You sure
him
it
Ralph.
isn't? You sure it isn't a female? Maybe you could.
Well,
call
I
it
don't
Lily.
know. I don't know enough about them.
Oh.
So we'll just call him Ralph, okay?
Okay.
Now let's get him out of here. He's walking along the edge. I'll put him out over here on the table so you can see better. Oh, watch what happens with his back end if he continues to go forward. Keep going now. Watch this.
It keeps curved all
See
the
how
way
it kept
down.
there? And look at the wave going down his feet.
Yeah, gee.
I think he's cute, don't
it
you?
looks like when you toss a rope when you.
Yeah, waves go down. Now come back.
That's right.
There.
Seems trained.
Now, what we're gonna? Oh, the millipedes have 13 to 200 pairs.
Wow.
Can you imagine them?
Do they also have one pair to each segment?
No, they have 2 pairs in each segment. And except for the front segments, I think there's only 1 pair on each of the 2 front segments or something like that.
I won't bother counting.
No, I don't think you should bother. So anyway, there he is,
Yep.
and I'm glad he woke up enough to
Say hello.
all right, come on. Back into your rotten
So
old
long,
leaves
Ralph.
there and relax. Well, now we've looked at the various methods of walking, and you see how complex it gets. Now we're going to talk about animal speeds, and the speeds are usually not done with walking.
No, my
but
running.
rather for running. And running is an entirely different mechanism, you know, because the feet work in
Yeah.
different ways. But let's do a guessing game. I have a
Okay.
list of animals, and I have a list of speeds, and let's see how good you are. Here it is back here. You come on around over here and put it out. I'll put it up here, and I'll show you what I want you to do. Here's a list of animals.
Let's see. Man, horse,
After
pig,
after man, they go by size. See, horse, pig, greyhound.
rabbit, cat, squirrel, mouse, spider, cockroach, and caterpillar.
And here are the miles per hour that they go. But they're not in the right order.
I didn't think so.
I started with the slowest one here and put the fastest one down here.
I
So what I want you to do is to decide which you think is the fastest and put it opposite here and make a new column.
Oh.
See how good you are.
Well,
What's the fastest one?
let's see. Probably the horse. Where was
Okay,
it?
that's in the bottom.
43?
43.
All right. I don't think that's wrong.
Okay,
yet.
now cross off 43. There. Now, what's next?
What would be next? Greyhound, I think.
Okay, and that's 40.
Yeah. That's probably wrong.
All right.
I get them wrong, probably.
What's the next fastest?
Let's see, 36. Rabbit?
Well, put it down, whatever you think.
Okay.
They seem to go pretty fast, don't they?
Yeah. I've never been.
Now, the next fastest was 30.
Pig, I think. Probably. They go pretty fast, don't they?
It's your guessing game. You put
I don't know.
You think a pig goes 30 miles an hour? Put it down.
All right, I will.
You know some pretty fast pigs, I'll tell you that. All right, next.
Should I change it?
No, no.
All right.
Yeah, what's next? 25 miles an hour, and of these,
Oh, probably man.
man.
I have to
Okay.
put him somewhere.
All right.
25.
Now,
What's that
next, after man,
Comes 12.
12.
Let's see. Squirrel, I think.
okay, squirrel.
They go
12.
pretty fast. They
Yeah.
go faster than a cat because it's hard for a cat to catch them.
Okay, that's good logic. So then you.
11 would probably be
The
a
cat. Okay. 11. Cross off the 11.
Oh, yeah.
Now you only have 4 left. Mouse,
no.
spider, cockroach, and caterpillar.
Well, the mouse goes the fastest of these, so that'll be 4. Right?
Okay.
Next, the cockroach. Well,
Which goes faster, spider, cockroach, or caterpillar?
cockroach.
Cockroach?
That's 2. And then the spider. Oh, yeah, spider. That's 1.3. And then.
And the caterpillar. Okay. Now I have the correct answers back here.
Don't show them.
I looked these up in various of my scientific books, and scientists have made many trials and sort of averaged them out and tried to get, good, healthy specimens and so forth. So while if you actually timed an animal, you might get slightly different times. But here on the average is what the correct answer is. Man, 25.
Oh, got that one right. I'll put a C there.
Horse, 43.
But again.
Pig, 11.
What?
Yeah, I told you knew some fast pigs. Yeah.
Well.
Okay.
Alright, so I got that.
Greyhound, 40.
Alright, that's okay.
Rabbit, 36.
Alright.
Cat, 30.
Alright, so I know some slow cats.
Okay. Squirrel, 12.
Alright,
Mouse, 4.
good,
Spider, 1.3.
good,
Cockroach, 2.
good.
Caterpillar, 0.5.
Well, I only got 2
Yeah,
wrong.
only 2 wrong.
Oh, that's not so
Well,
bad.
now, let's actually time one of these animals.
You don't have a horse.
No, we won't do a horse, but people think that cockroaches go pretty fast. Let's time a
Yeah,
cockroach.
they go pretty fast, alright.
Okay, you want to move that book down underneath there?
Okay.
See that stopwatch there? You want to take that
This,
stopwatch up?
yeah.
Because here is the cockroach racetrack.
And there's the cockroach.
And there's a cockroach in a little bag. You can see here's a yardstick. See?
And
1 yard from start to finish.
Right.
All right. Now, I figured it out earlier. If he goes from there to there in 2 seconds, he'll be going a mile an hour.
Okay.
All right? So I'll get him going. And as soon as he crosses the starting line, you push on the stopwatch. And let's hope he continues to go in one straight. He doesn't stop and talk or something. And as soon as he crosses the finish line, you click the stopwatch
Right.
off. And we'll actually time a cockroach. Are you
He
ready?
doesn't look very healthy.
Oh, he's perfectly healthy. I had him before. Oh, what do you mean? Look at that. Are you ready? Here, he's coming towards the starting line. They're lined up. There we go. Ah,
Not even 2 seconds.
he went a mile an hour.
Jeez.
You were pretty good with the watch, too. I thought you said he couldn't move. Now, does
Well-
that seem fast or slow?
I looked pretty fast.
It looked
for
pretty
real.
fast, yet when you say only a mile an hour, that doesn't seem very fast, does it? Why do you suppose people think they go so fast if they only go a mile an hour?
Well, when they see them going, they're small and they seem to just dart past.
Also, their legs move fast, don't they? And
Yeah.
they dart every which way. Oh, he's stopping.
Too late.
In fact, scientists have timed them and found that small ones can go, maybe a mile an hour, and big, large ones can go up to about 3 miles an hour. And
Huh.
yours went about a mile an hour, so that's about
Yeah,
average.
that's pretty good.
Well, you see how you can have a lot of fun timing. And in fact, you
Yeah.
should make more than one trial, and maybe we can try again later. But
Have a racetrack.
have a
and see all-
racetrack, you could have a cockroach race and have different, put marks on the back so that you'll know. Anyway, you see that animal movement is a fascinating study, and many scientists have spent a long time studying the very complex motions that take place. And I think if you and I are going to be good scientists, you think we should try one more? You
Yeah,
ready?
just for the
Okay,
record.
because if you're going to be a really good scientist, you should do it more than once. Are
Yeah.
you ready with a stopwatch?
Right.
Okay, here we go. We'll be good scientists and time it several times. Ready?
Ready.
On your mark, get set, go.
Well, that one won't count.
Watch Mr. Wizard is presented each week at this time by the Public Affairs Department of NBC News in cooperation with New York University.
Watch Mr. Wizard. Now, Mr. Wizard's not his real name, but that's what all the kids in the neighborhood call him, because he shows them the magic and mystery of science in everyday living. Buzz, one of the kids in the neighborhood, is coming in the door right now. So let's join him and watch Mr. Wizard.
Hi, Mr. Wizard.
Hi, Buzz.
What you doing?
Well, what does that look like to you?
See a volcano.
That's right, that's a volcano. Right now it's erupting.
Gee.
Really goes on, doesn't it? And also
Yeah.
makes things that makes me sneeze, I think. Excuse me. Well, you see, what you and I are going to talk about today is the world under our feet.
In your nose.
Getting in your nose, too, huh? And at one time, the earth that we walk on was once all molten liquid. And as it began to cool, a crust formed on the outside and got deeper and deeper, but inside the earth it's still very hot. And when some of that heat and molten material goes up through the earth, it forms a volcano.
Volcano.
Now, there are still some volcanoes around the world in various places. Do you know where they are? Here's a map. See if you can find some.
I only know a few of them. See, there's one in Japan.
One in Japan, that's right, Fujiyama.
Then there's one in the Hawaiian Islands.
That's right, and there's some others in the South Pacific. In fact, you remember a little while ago an island blew up?
Oh,
and
yeah.
disappeared? That was because of a volcano, yeah. How about in the our part of the world?
Mexico.
That's right, there are several in Mexico. Over in Europe?
I know there's some over here, but I don't
That's
know
right,
where
over
where.
here near Naples is one called Vesuvius.
Yeah, wasn't that the one that buried the city of Pompeii?
That's right. There's also some in Sicily. And, you know, our Rocky Mountains and the Alps and the Himalayas over here probably at some time had volcanoes in them also. So you see some of that heat that was in the center of the earth is still bubbling out and forming a volcano. Now, let's take a look at what happens when we have a volcano. I've got a new one. We're going to make another volcano over here. This time I'm going to have you set it off.
That's big.
Okay? And in order to do that, you put an eyedropper full of this liquid right on the top.
Oh?
Yeah, whole eyedropper full. It's dormant. Nobody suspects that there might be a possibility that the mountain will erupt. Just to help it along, put more liquid on it. It begins to smoke.
People start looking up.
Mm-hmm. They
Start
start
to
now
wonder.
moving away.
Start to run.
There she goes.
There she goes. And they run like mad.
They sure do.
And they start to be buried.
Now notice this fine ash that's rolling down the side of the mountain. That's the same sort of ash that buried the town of Pompeii. Sometimes when water gets into the volcano, for instance, if there's a passageway underneath the ground from the ocean and water gets in there, and the lava gets mixed with water, it forms steam and little tiny bubbles form in the lava, and when it is blown out of the mountain, it rolls down in this form, also goes into the air in this form, and sometimes lands in the water and looks like this. See the little holes?
Oh, yeah.
Well, this is a form of material that comes from the mountain that is known as igneous rock. All rock that is formed by fire is called igneous. That's one of the words I want you to remember.
Formed by fire, igneous.
Igneous. You going to sneeze too?
Almost.
Well, what do you expect being here near an erupting volcano? That's what the word means. Fire formed. Igneous rock. This is one form right here. The specific name of this is pumice. In fact, because it has so many little holes on it, even though it is rock, here, drop it in that glass of water. See that?
Floats.
It floats, that's right. And would actually float in the ocean. Now, when they find pumice like this, they can very often grind it up into a fine powder like this. Here, put some of that between your fingers. You know how very fine it is?
Yeah.
At the same time, you feel it has a grittiness.
Hard.
Well, they use that for polishing. Sometimes they form it into a stone, and it's called a pumice stone. That's one kind of igneous rock. Now, this time, you keep an eye on that volcano, because this time lava is going to come out.
Lava?
In fact, watch. See, while it's bubbling away here, not only pumice is coming out of it, but this time real lava. See it? Rolling down the side of the mountain. I'm helping it along just a little bit. Now, that form of rock, when it comes out, this is igneous also, right? Because it was formed under fire, or by fire. It rolls down the side of the mountain and begins to cool. And would look like this, for instance. See, there are various types.
I thought lava was black and hardened like cinders.
Well, the top surface of it, you see, that would be exposed to the air with so much heat would oxidize, and so would look more like cinders. But down below, where it's just plain hot and melted, when it cools, it finally could form something like this. Some of the lava, when it cools, is black. In fact, you recognize this?
It's granite.
And granite is igneous rock. In other words, formed by fire and laid down on a layer sometime. Well, I have a special little landscape over here. See, here's my little landscape, and we're going to investigate the various kinds of rock. Here's a mountain over here with, we might say, a big piece of granite, so you know that what is this black sort of stuff?
That's igneous rock.
Igneous rock, formed with fire. You see how it runs all the way over? There's another
there.
piece over here. So let's put a little sign up here, so we'll remember that this is igneous. Formed from fire. Well, now, something happens to this igneous rock. We don't have igneous rock all over the place.
No.
Things begin to tear it apart. Well, let's see if we can find out what it is that tears this igneous rock apart. Now, you see this lava? Here it is down here, beginning to cool, see? This lava right down here would have bumps and holes in it, just like this has, see? And water could flow in there, couldn't it? And more lava could cover it, perhaps, and they'd have little pockets and cracks all full of water. All right, now, what if the temperature changed and it got very cold and the water could freeze? Strange things would happen. In fact, here's a very cold liquid over here. Let us pretend that this is igneous rock that has water in it. And let us get it nice and cold by putting it in this special bath.
Is that, liquid oxygen?
No, in this case, using dry ice or solid carbon dioxide and acetone to get it very cold. Well, let's also pretend that this bottle was made of igneous rock. Inside is water, cap on the top. If we put this igneous rock in and get it very cold, what do you suppose is going to happen to it?
I know.
What?
It's gonna crack.
You think so? Well, keep an eye on it. Getting colder and colder, gradually forming into ice. Did you hear a crack?
Yep.
I did. I don't know whether that was a little bottle.
Yeah, it cracked a
began
little
to form
bit.
cracks. Yeah, the ice is holding it together. There, you see the cracks forming into it? And gradually, as it got colder and colder, it could pry the igneous rock apart. There's one way of going over there, too. In fact, let's take a look at our... see if there are any cracks in that yet. No, let's leave that in there for a while and let it get nice and cold. Well, you can see how that crack would form. And get wider and wider as the ice began to, push on the sides and begin to break that igneous rock up into pieces. That's one way that it's broken up. Then what about when it was very hot, either from the heat of the earth or the sun beating down on it? If it were solid material, something like glass, and you heated it up and it heated up unevenly, what would happen to it?
Well, it'd break.
Sure, it would break.
Oh, yeah, I know that. I've taken a glass and get it real hot, and then accidentally it gets real cold.
Breaks. Something like this, huh? In fact, see this stove over here? Let's pretend that that's the heat on the inside of the earth, and here I have some glass, which would be the igneous rock, and which had cooled, and now when it was heated up again, well, all kinds of things could happen, right? Now, this same sort of thing happens to igneous rock to help break it up into various pieces. Bam! Really went, didn't it? Didn't need to turn the other one on. In fact, let's push this one over, because at the same time as it was forced apart like that, with heating unevenly, if it should also rain or water should fall on it, it's not hot enough yet. Because sometimes when you put water on it, not only does it crack into great big pieces, but it also cracks into little tiny pieces.
Not quite hot enough.
Not quite hot enough. You know what? Every time I put the water on there, it cools it off, right? And keeps it at what? 212 degrees. Because that's the temperature at which water boils. There we go. Now, let's take a look at that piece. There, do you see? Whoop. See this little piece right here? Oh, it's all cracked up into little, tiny little slivers. Well, that same sort of thing could happen to the rock. Well, that's another way that igneous rock is broken up. Besides, ice also changes in heat. Now, can you think of any other method that igneous rock might be broken up?
Wind.
Wind, especially when it carries little pieces of sand.
Yeah, like a sandstorm.
Like a sandstorm could go by and knock off pieces. How about another method?
Rain. It could wash it away.
That's right, it could wash it away. And when you combine all those various methods, gradually you're gonna tear the igneous rock down, and some strange things happen to it. Come on over here, I'll show you. You're going to be the rainstorm, the rainmaker. Mr. Johnson, rainmaker. I'm going to be heat and ice and wind and rain and wear this rock away. And you pour the water over here, so it'll be the same as when it rains on the mountain when all these things are happening. See how the various types of igneous rock would be worn away into little tiny pieces and carried by the water. Notice down there we have a lake. Be careful you don't have it rain too much so our lake overflows the shores, huh? Okay, that's enough. Now, what's going to happen when all this material gets down there to the lake? Let's take a look. See what happens?
Gee, all the sand and all the rock and pebbles and stuff, they all went to the bottom and made a layer.
And they formed a layer. And adults would call this a sediment. Have you ever heard that word? Sediment,
know.
a layer on the bottom of something.
I think so.
Well, when there's enough weight of water pushing down on it, it is no longer individual pieces, but it's so much weight it pushes them together and forms a rock that might look something like that. Take a look at that.
Oh, yeah, you can see all the pebbles and all the sand, and it's all forced together to a
And
rock.
now this is no longer igneous rock, but it's called sedimentary.
Sedimentary
Sure,
rock.
because it was sediment and now formed into a rock. So let's go up and take a look at our landscape over here. See, here was our igneous that was worn away and formed a layer down here of sedimentary. And you know, when you see sedimentary rock like this, that at one time it was under a lake or an ocean. So let's put our sign here, sedimentary, like that. Now, what happens when some of this sedimentary has enough heat and pressure put on it? All kinds of strange things. We get a new kind of rock back here. Let us pretend that this is a mixture of sedimentary rock. I'm going to put heat and pressure on it with this, a nice hot iron. Watch what happens. Now, as this begins to cool off, remember we had heat and pressure on it. As it begins to cool off, it now forms a new kind of rock called metamorphic. And that comes from the Greek. Meta meaning change and morphic meaning form.
Metamorphic.
A rock that has changed form. And when this cooled, you see, we would no longer have little individual bits of wax, but a whole thing bound now into a new form called metamorphic. And I've got some samples of that over here. Oh, by the way, another very interesting aspect of rock that didn't come from igneous. Remember, that was the fire type, right?
Yeah.
You see, let's take a look at our ocean here. In this ocean were all kinds of little animals and plants. And they took calcium out of the water and used it to make skeletons and shells like this. Okay? Calcium carbonate they changed it to. And as they died, they fell down to the bottom and formed a layer
They were
too.
heavier.
They were heavier. Until pretty soon there was a lot of pressure put on them also with the weight of the water, and they formed a kind of sedimentary rock also.
You mean they were forced down so hard that they bound together to make a rock?
Right, they make a rock. Now, scientists can check the presence of calcium carbonate in a shell by putting some acid on it. So you take that eyedropper and put just a drop of the acid on that shell. See how it bubbles up?
Boy, it bubbles and foams. And
And here is a piece of rock, a sedimentary rock, that was made out of those shells.
yeah, all the little shells
See, you
on
can
it.
see little tiny shells on it over here. Well, now, if it's true that scientists can check for calcium carbonate in the shell with the acid, how about it putting a drop on here?
We can
Okay.
find out.
Okay, try it. See how it bubbles too?
Yep,
So they know
just like the shell.
that this has calcium carbonate in it and probably came from shells. And this is a form of sedimentary rock. Now, when you had great heat and pressure put on this sedimentary rock, now it changed to what? Metamorphic. Okay, this kind of metamorphic rock could be changed into this kind. And what does that look like?
Looks like marble.
That's right, that's exactly what it is. This kind that we looked at first over here is limestone. And when limestone has heat and pressure on it, it's changed to metamorphic rock called marble.
Oh. Say, Mr. Wizard, if the animals got calcium for their shell, and then the shell went into the
Limestone.
limestone over
Yeah.
there, then that was changed to marble. Well, then we should be able to put the acid on, and the marble should fizz and bubble and foam.
Sounds logical, doesn't it?
Mhm.
Well, try it.
It does.
It does. Congratulations, Mr. Johnson. You're going to be a geologist yet. And now you know that came from the bones and skeletons of little animals, right? Here's another form of metamorphic rock. See, it looks a little different.
Test it.
Oh, we'll test it and see if it is once was limestone. No, wasn't limestone. Well, but they both were metamorphic, meaning changed from some other form. Okay, now we can go back and look at our landscape again, can't we?
Yep.
You see, here was our igneous, and right here, this rock down here, at one time was sedimentary. But igneous rock flowed over it, heated it up, put pressure on it, changed it to metamorphic.
Now we have metamorphic.
And we have some over there also, right? Okay, put the metamorphic up here. Now we have the three major kinds. Igneous, formed from fire, which would be this lava, basically like granite. And sedimentary, which was formed at the bottom of a lake as a sediment and then pressed into rock. And metamorphic, the original sedimentary rock was changed with heat and pressure into something else. Now, and many times this doesn't have to be found under the ground because let's say that at one time this was all under the sea, a great big sea here. And then eruptions took place and the earth changed and moved and some of the metamorphic rock was shoved right up here. So right out here you could mine marble. And also at the same time an igneous shaft pushed itself right up to the ground and right here you could mine granite. And notice that it pushed the sedimentary rock in various ways. So now we have the three kinds, igneous, sedimentary, and metamorphic. Okay, now I have a very unusual specimen to examine. Would you help me move away this trough here? And you can also move that glass out of there. Here's the specimen right here. What do you think of that, Mr. Johnson?
A very interesting specimen. Is it igneous?
No, I wouldn't say that it was
No,
igneous, would
not
you?
quite.
I wouldn't think so.
Is it sediment or what?
Sedimentary?
Yeah, sedimentary.
Well, I rather doubt it, would you?
Well, then it's metamorphic.
No, I don't even think it's metamorphic.
Well, then what is it?
Well, why don't you examine it very closely?
Well, there's some layers,
Yes.
and that means that each individual layer was stuck on the other one, and then they were packed together to make this rock.
Right. In fact, you can see those layers very often, when you go up a hill and they've cut away the top of the hill, and you can see the layers
Yeah.
formed like this. Well, sometimes it takes thousands of years to just make one of those layers.
Well, how many years did it make let them make this?
Oh, just a few minutes, I'd say.
A few minutes? Well, see, Mr. Wizard, there's some arrows on top of here. Well, are they possible that that's fossils?
Fossils? Well, I don't think so. Fossils are the shapes of shells and animals and leaves that have been pressed down between the layers and left their form. These were made with, I'd say, a sharp instrument, so I think that etchings would be a better word.
Oh, well, were they made by human beings?
Oh, naturally.
See, Mr. Wizard, isn't it kind of funny that all the arrows are pointing one way?
Well, let's check that side over there where they're pointing.
Say, there's some writing on it. It says, open here. Well, this is a rock with its built-in instructions.
Built-in instructions. Well, are you ready to follow the instructions?
Okay.
Well, here, let's see if we can pry the layers apart. You ready?
Follow the rules of good health.
Well, you certainly know those, Mr. Johnson, don't you?
Oh, sure. If I get plenty of sleep, exercise, fresh air, water, and rest, or 3 well-balanced meals a day.
Right. Are you ready to examine the next layer?
Great.
Right.
And here's the way to get started on those rules of good health. With a good breakfast of fruit, cereal, milk, bread, and butter.
Right. That's the way to get started on those rules of good health every morning. Now, the reason for that is, Buzz, nutrition experts have found that it's very important for all of us to get from 1/4 to 1/3 of our whole day's food needs from the breakfast we eat. And they've also found that there's no better way to get them than from a breakfast, well, like this one over here, for instance. See? A breakfast of fruit, cereal, milk, bread, and butter. Or other foods for variety, like eggs or breakfast meats.
I like a breakfast like that every morning because it tastes so good.
Well, it certainly does taste good, Buzz. But in addition to that, doctors found in a series of tests on college boys and girls at a big Midwest medical school that when you've had a good cereal breakfast like that one, for instance, you're able to work better, you're a lot keener and sharper, and your muscles won't get so tired, especially during the late morning hours.
And that's why I say it's smart to start every day with a good breakfast of
Fruit, cereal, milk, bread, and butter. Right. Now, you see, sometimes geologists can make very important discoveries.
Well, we did.
Such as the one we made over here, right? In fact, you know what I made that rock out of? Remember, it was a man-made rock? I know because I made it, see? It took me just a few minutes, and I used kind of a form of sedimentary rock called clay.
Oh.
And when clay, as a sedimentary rock, is changed to metamorphic, you know what it is?
What?
Slate.
Slate.
Slate, yeah.
You know, like the blackboards?
Like the blackboard. And they also make roofs out of it, don't they? Well, so far now, we've made several important discoveries, but we still have a little problem here, in that ordinarily when we walk on the ground, it isn't any one of these. It's sort of a black dirt, isn't it?
Oh, yeah.
Soil. What do you suppose that is? How did that get there? What is
Well, maybe it's a form of igneous and sedimentary and
metamorphic?
metamorphic all mixed up together.
Well, it could be, but there's a special element that's been added. See this hot plate over here? Well, I got a can cover on the top. I'm going to put a mixture of metamorphic, sedimentary, and igneous, called sand, on one side of it. What happens?
Nothing. It just gets hot.
Just gets hot. Okay, now on the other hand, on the other side of the can, I'm going to put some of this black stuff that we call dirt or soil. And you watch what happens. See?
Boy, that smokes.
It sure smokes. Does that give you any clue as to what might be the other ingredient in soil?
Burns.
It burns. What is it that you put in the fireplace and it burns? Smokes? Wood. Well, the material that's in soil that makes it different from sedimentary rocks and all the other things is organic material. That means at one time it was growing like a tree. It fell over and, when it went into the ground, it decayed and had a lot of carbon in it. That's why the dirt is black. And it's a mixture of this organic material and this sedimentary, igneous, or metamorphic rock that makes soil. And that black stuff is very important because that contains the food that plants need to grow on. And so it's usually known as topsoil because it's found on the top layer here. You see where the trees are growing? That would be known as soil. And sometimes it takes thousands of years to just make an inch of it. And sometimes it blows away with the wind, and erosion. So that would be soil. So let's put a soil sign up here, like that.
Now we have them all.
Now we have them all. What was this?
Igneous?
Igneous, yes.
Igneous.
What does that mean?
Well, that means fire.
Came from
Yeah,
fire.
came
yes.
from fire.
Right, and an example of that is what?
Granite.
Granite. Okay. How about this white stuff right here?
That's sedimentary.
What does that mean?
And that means, like the sedimentary.
Formed as a
Yeah,
layer.
yeah,
Formed
as a
as a
layer.
layer, that's right. And what is a good example of that?
Limestone.
Limestone. Oh, that was formed, remember, out of the shells and the skeletons of animals,
Yeah.
and not from igneous rock.
Yeah.
Okay, now, what is the other kind?
Metamorphic.
Very good. And what does that mean?
Well, that means change form.
Change
Change
form.
form.
Right. And what's a good example of that one that you know?
Marble.
Marble, which came from limestone, right? Well, fine. And finally, you have soil, which has an important thing added to it. What is it? Organic. Organic material. In other words, it was growing at one time. And incidentally, by the way, some of that organic material could be down here in the sedimentary when it folded over and be buried down in here, and they'd later get it out as coal.
And oil, maybe.
And oil, sure. So there we have the various types. Now remember, we had a man-made one over here. Well, man actually makes a very good rock. It's a combination of sort of sedimentary and metamorphic put together, and he calls it concrete.
Oh.
In fact, I've got some concrete over here. In a special kind of tester, because it's surprising how strong man can make his own rock. Here's the concrete down here in the form of a block. And they use this machine for testing concrete to see that it will hold up under the load that is necessary, see? So here's the dial up here. And it's going to keep track of the number of pounds I put on with this hydraulic press, so you watch. You read out the number of pounds.
200,000.
How many?
200,000.
20,000.
20.
There's 30, we just passed. Now
30.
40,000. A little below 50. There, we're a little below. Now we're coming to 60,000. Almost 70.
70.
There's 80,000. 90,000. Pretty soon we'll get up to 100,000 pounds. There's 100.
100,000.
There's 100.
No.
There she goes.
More.
See how much? 100. Well, it was about 130,000 pounds. And take a look at man-made rock. See why I said it was sort of like sedimentary? Because it has all these bigger rocks in it held together with a thing called cement. And there's a changeless form, too, because there's a chemical reaction that takes place in it. That's why I sort of was sort of like metamorphic also. Well, now that you know all about these various kinds of rocks, I think it's about time for you to go home, and the next time you go out on a hike, see if you can guess what kind of rocks they are.
Okay. What are we going to do next week?
Well, next week, Buzz, we're going to examine science in the circus. And we're going to find out why this little man is so good at balancing. Here. You take that loop, you walk over there by the table. Like that. See this little man here? Well, he's sitting on a little bicycle. See? And he's so good at balancing that you can put him on this tightrope. Here, you step back just a little bit with you there. Fine. You can set him here on this tightrope on his little bicycle, and not only will he be able to stay on the bicycle, but he will ride. Now, there's a very important scientific principle about why that man stays on the bicycle, and next week we'll find out all about it as we examine science in the circus.
Don't forget to be with us next week for another exciting program of mystery and magic and everyday things when the Serial Institute again invites you to watch Mr. Wizard. Oh, yes, and by the way, Mr. Wizard lives in Chicago.